Hey guys, I've got another new video for you. I hope that the first one was fine, but I thought I should redo this and make it a little easier for people. So today we're going to talk about absolute value functions and their graphs. We're going to move absolute value functions up, down, left, right. We'll flip them upside down. We'll do it all at once. But if you could just know that an absolute value graph is typically a V-shaped graph that's going to give you a pretty good head start into the lesson. Let's start with some vocab. Absolute value function is f of x, which is just y, equals an absolute value of x. That's as basic as it gets. It is a V-shaped function. It's going to look like a V. Could be upside down, could be moved left, right, could be shorter, taller, but it's going to be a V. The axis of symmetry is the line on the graph that the function is mirrored around. So if we have our V-shaped graph, the axis of symmetry would be an up and down line right there through the middle because you could fold it on that line. Okay, so the axis of symmetry is that dotted line right there I just drew. The vertex is the middle point. I guess we can call it the middle point. Maybe even like the starting point of the graph. All right, now I don't know why I wrote if it exists. Maybe I wrote that there because if it's not an absolute value function, it's not going to have a vertex. Maybe a linear function. I don't know. You can ignore that little rule. All right. We can do the warm-up problem later, but let's talk about this translation stuff here, or the absolute value equation here. So all this is really saying is that when you have an absolute value equation, you can make an XY chart. When you plug in -3, out pops a +3. That's what absolute value does. -2, out pops a +2. -1, out pops a -1. And all the positives pop out a positive. All right, that's what absolute values do. As long as there's not a negative sign on the outside, then whatever you plug in is going to be positive. And that, when you plot your points, you're going to get that V shape right there. The axis of symmetry is the line down the middle. The vertex is the middle point. Problem 1. How would you graph? I guess that, or it says, that should say, how does this equation, I'll fix that on yours, how does y plus 4 equals absolute value of x compare to the parent function of y equals absolute value of x? Use an XY chart to graph it. The first thing we need to do is, you see this 4, we need to take him to the other side. So can you please write a -4 on both sides? We need to get this in y equals. So we're going to have y equals, put the absolute value of x first, and then put that -4 in the back, okay? So I had a little trick there that we had to solve for y. To make an XY chart, we're going to just drop it down. I have not moved this left or right. Hopefully you remember that from yesterday's notes. Like, see how there's nothing inside with x? I'm not moving it left or right, so I'm not going to change my x values. I'm just going to keep my normal x's we taught you to pick in Algebra 1 to get a pretty picture. And I'm going to plug those in. So I'll show the work on this one. Do the absolute value of -2, plug it in for x, -4. The absolute value of -2 is 2, -4 is -2. Let's plug in -1. The absolute value of -1, -4. The absolute value of -1 is 1, -4 is -3. Let's plug in 0. The absolute value of 0 is 0 -4 is -4. Let's plug in +1. The absolute value of +1 is 1. -4 is -3. Let's plug in +2. The absolute value of +2 is 2. -4 is -2. Let's plot our points. So we go -2, -2. So that's left 2, down 2. -1, -3. So left 1, down 3. 0, -4, left and right 0, down 4. Look, you just found your vertex. It's your middle point. 1, -3. See how we're going to make that V shape now? And 2, -2. So right 2, down 2. You can keep going with your XY chart, but you should notice that it's got a nice little pattern here. It's going to form a perfectly shaped V. That's the absolute value function. Now, we didn't answer the question, how does it compare to the parent function? The parent function was this one right here. Since we added a -4 in the back, let's circle it. Since we added the -4 in the back, that moves it down 4 units. And as you can see, it looks like this thing has literally just been like bloop, plop down 4 units. The axis of symmetry is the line it folds around. I'll get a ruler to try to emphasize that. So you see this ruler, how I have it here? I'm trying to make it look nice for you. I'm not doing a very good job. There you go. That looks pretty good. See how that's the line that it folds around? That's x equals 0 because it's right smack dab on your y-axis. Axis of symmetry, x equals 0. All of that, not just 0. A lot of kids always write just 0, but it's x equals 0 to tell me it's a vertical line. All right, problem 1a. What is the graph of this function? XY chart, excuse me. It's not moving left or right. See how x is by itself? It's not moving left and right. This plus 2 in the back is going to move it up 2 units from the origin. All right, let's plug in our normal. -2, -1, 0, 1, 2. And let's see what we get. So we'll do the absolute value of -2 is 2 plus 2 is 4. And we can keep that going, or maybe we can just do it in our heads. Ready? The absolute value of -1 is 1 plus 2 makes 3. The absolute value of 0 is 0 plus 2 is 2. The absolute value of 1 is 1 plus 2 is 3. The absolute value of 2 is 2 plus 2 is 4. Notice this is your vertex. It's where everything reflects around. Everything up top is the same as everything below. Let's plot our points. -2, but this time up 4. 1, 2, 3, 4. -1 up 3. Left 1 up 3. Over 0 up 2. There's going to be our middle point. Over 1 up 3. Over 2 up 4. Let's connect. And we have a perfect graph. Axis of symmetry, again, it's right there in the middle. Do you see it? You just write x equals 0 because it's right smack dab on your y-axis. And hopefully you understand this one has been moved up 2. Part B says, do the transformations of the form y equals absolute value of x plus k affect the axis of symmetry? So they're asking, when I put a number in the back, does that change the axis of symmetry? The answer is no, because the axis of symmetry, it doesn't move. Since our graph isn't moving left or right. Our graph isn't moving left or right. So the axis of symmetry stays at x equals 0. The graph just moves up and down the axis of symmetry, which means it still folds on the same line. Now the translations we talked about yesterday are still the same. If you add a number in the back, it moves it up. If you subtract a number in the back, it moves it down. Okay? If you have a minus on the inside, it moves it to the right. If you have a plus on the inside, it moves it to the left. If you have a negative on the outside, it flips it upside down like this. If you have a negative on the inside, it flips it left and right like this. If you have a number that's bigger than 1 on the outside, it's going to be a super skinny V. It's going to vertically stretch it. Whereas if you have a fraction like 1/3, 1/2, 1/5, 2/5, something small between 0 and 1, is going to vertically compress it. It's going to be a really fat V. All right, let's take all these and apply them. And look, we got some multiple choice, so we can just hopefully eye things up. What is the graph of, oh, look at that funny 3. That 3 is not where it should be, is it? That needs to move over to the other side. Y minus 3 equals absolute value of x plus 2. Let's get that 3 on the other side, okay? So put plus 3 here, put a big plus 3 in the back there, cross this one out. We don't need it over there. We want it on the other side. So really we have y equals x plus 2, absolute value, plus 3. Let's talk about what this means. The plus 2 on the inside, that means move it left 2 units. So it's going that away 2 units. The plus 3 in the back means it moves up 3 units from the origin. So let's find which graph satisfies that. This one has moved left 2 but down 3. This one has moved right 2 and down 3. Remember, I need left and up. This one has moved right 2 and up 3. This one, here it is, left 2, up 3. There's your vertex, left 2, up 3. I don't know how you want to show that, but that one is the left 2 up 3 1. That's your right graph. All right, on this one I was a little sneaky. See, this entire box is on the wrong side, so I have to add it to the other side. Just add the entire absolute value. It looks really weird to add an entire absolute value, but this is how you do it. So you add the entire absolute value of x minus 2 to the other side so you can move it over. We have to have y equals, okay? It's super important. So we're going to put the positive absolute value of x plus 2 first. Or I'm sorry, it was x minus 2. I apologize. And then that 1 is a positive 1, so we need to add it to the back. So this graph, a minus on the inside, is going to move it to the right 2 units. Sorry about that bell. The plus 1 in the back is going to move it up 1 unit. So which one of these graphs looks like it's been moved right 2 and up 1? Notice they're skipping by 2's just to mess with you a little bit. This one has moved right 2, up 1, so B is the option. This one moved to the left. All this little paragraph is saying is that you can flip it upside down if it's negative on the outside, and it can have a slope of whatever the number on the outside is. Which leads me to, if you didn't like using the XY chart, you are not alone. I'm going to teach you about a little shortcut we can do. In order to do the shortcut for graphing, it's actually really nice. It's super similar to y equals mx plus b. We are going to skip the XY axis part, or the XY chart part, which I think should make some of you very happy. But if you get stuck, by the way, XY charts always work. Just be careful when you move things left and right. All right, here are your steps. Step 1, solve it for y. That should be a very familiar step for you. Step 2, find the vertex, which is the middle point of your graph. It's opposite of what you see on the inside and exactly what you see in the back. Number 3, find the slope. It's the number in front of the absolute value signs. It's the number in front of the absolute value signs. Once you have those two things, you plot the vertex, like an XY point, and you use the slope to make a graph. Negative means it's upside down. Positive means it's right side up. The next video, we're going to apply this in problem number 3.